So as we read this problem, we see that it says the time required to complete an oil change is approximately normal. That lets us know that we're going to be using a normal distribution. That means the distribution of the time required to get the oil change looks like this. There's a mean of 15 minutes, so the mean is 15 minutes, and a standard deviation of 3 minutes. So that means it takes 3 minutes to make the standard deviation. So sigma is 3. The center guarantees that the service will take no longer than 20 minutes. So 15, 16, 17, 18. So 20 minutes would be about here somewhere. It should take no longer than 20. If it does, the customer will get a service for half price. So if it takes longer than 20 minutes, the mean is 15, that's right in the middle, and longer than 20 minutes would be out here. So that we're talking about that percentage of customers that would get a discounted service. So the question is, what percent of customers receive the service for half price? Percent, proportion, probability, area. That's the question in part A. What is the shaded region? What's the area under the curve? What's the probability that a randomly selected person goes to get an oil change and it takes longer than 20 minutes? So to do part A, we have two options. We can calculate this thing with the by hand method. And by hand, obviously you're going to still have to make some calculations. You just won't run the whole thing in your calculator. So in by hand, we're talking about the probability that X, some randomly selected person, it takes them longer than 20 minutes to get an oil change. Well, we don't know anything about the distribution of X except that it's normal, so here's the curve, and I'd rather not use calculus to find the area under the curve. So instead we're going to convert that X to a Z because we have a table for Z value. So instead of X, let's make Z. Z is X minus the mean divided by the standard deviation. We've done that in chapter 3. So the X value we have is 20, the mean is 15, the standard deviation is 3. We have 20 minus 15 over 3, that's 5/3, or 1.66667. Alright, so now our probability statement has been transformed. What's the probability that Z is greater than or equal to 1.67? Now we can use the table. That means we want to find this value in the Z table. We want the area to the right of 1.67. on the standard, normal, or the Z tables. To the right, because look at the shaded region we made there. It goes to the right. So let me open the table. Here's the table, areas of the standard normal distribution. The shaded region here is area to the left, but we want the area to the right. So let's read the area to the left and take it from 1. Our Z value, remember, is 1.67. So once I get over here to the positive region of the table, the first two digits are here. 1.6. And then the last digit is 7.07. Oh, doesn't highlight quite how I would like it to, but close enough. You see that the overlap is right there. 1.67 is 0.9525. Now remember, this table tells us the area to the left. See this picture up here? That's area to the left. So I want the complement of that. What I'll do over here is say that this probability is 1 minus the table value at 1.67, or 1 minus what we saw at the table was 0.95 something. Pull it back up, 9525. That probability, 1 minus 0.9525, is 0.0475. That's the probability that a customer will get the discount on the service, or that it will take them longer than 20 minutes to complete the oil change. Now that's the by hand method. We can also do the calculator method. The calculator method requires that we exploit this normal distribution. So as you can see here, we have a normal curve. The problem said it was approximately normal, so in the distribution menu, second variables, number 2 is the normal cumulative density function. That's the thing that will calculate this area for us. The lower bound, the smaller end where we start caring about this area, is 20. That's the 20 minutes. The upper bound, it doesn't matter, it just keeps going, right? So you could say 100 or 1,000 or 10,000, something sufficiently large to capture all that area. The mean of the distribution was 15 and the standard deviation was 3. We gleaned that from the problem. So if we put that in, if you don't have that input menu in the calculator, you'll still run the normal CDF. It will open a parenthesis. You need the lower bound, 20, the upper bound, 100, 1,000, something like that. The mean, 15, the standard deviation, 3. So that's the input. Lower, upper, mean, standard deviation, always that order. Press enter and it will calculate the probability for you, 0.0478. So you see that these two problems are off just a skosh from each other. The calculator obviously is the more accurate one because it doesn't have any rounding errors. The table only could go to 4 decimal places, so it's slightly less, but not enough to matter. Should be within the tolerances of MyStatLab, certainly within the tolerance of the answer acceptance on the final exam.